Alright, so welcome to the first video of a series of videos for truss analysis. So what is a truss? All of these are examples of trusses. And the reason why they exist is because instead of making a structure with one piece of material, we can make a really stable and rigid structure using many pieces of the material. So obviously it's going to be cheaper to make a structure with less material. So trusses can be arranged. Like you can see, they can be arranged in any way. And these are just a few examples, but trusses can be arranged in absolutely any way. And they're found in like roofs, bridges, even in cranes. So they can be found in many structures. But this is the simplest form of a truss. And what makes this a truss is it has these long, narrow parts, which are called members. It has connections. It has connections at each end. These are the joints. And it also has some kind of support where we're going to have the reactions. So what's important to understand is that the basic structure of a truss is a triangle. It's going to be some sort of a triangle. And you can build off this basic structure by adding more triangles or just adding more sections, depending on what kind of truss that you need. And you can end up with something that's a bit more complicated or different shape. So something that's really important to determine is whether the truss is stable or unstable. And stable trusses, we have determinate and we have indeterminate. So we have these two types of stable trusses. And for our unstable truss, we just have unstable trusses. We can't do anything with unstable trusses. So we need to identify first whether the truss is stable or unstable, and then we need to identify whether it's determinate or indeterminate. And then we can begin to analyze a truss. And there's a really important formula that we need to know, which is B plus R is equal to 2J. So B refers to the number of members, R refers to the reactions, and J refers to the joints. So if we count up each part of the truss, so with this simple example, the number of members we have 1, 2, and 3. We have 3 members plus. So for our reactions, we have 3 possible supports. So we have a fixed support, we have a pin support, and we have a roller support. Right, it can be drawn like this. So fixed support, we're going to have 3 reactions. We have a reaction in the vertical, a reaction in the horizontal, and we have a moment. In the pin support, we have a reaction in the vertical and in the horizontal. And for roller supports, we'll have a reaction only in the vertical. So if we look back at our simple example, we have a pin support here. We have a pin, which will be 2 reactions, and we have a roller support, so we'll have 1 reaction. So our total reactions will be 3, and this will be equal to 2J. So the number of joints, we have 1, 2, 3. 3 joints is equal to 2 times 3. So 6 is equal to 6. That means that this truss is stable. So in the next video, we'll look at a few more examples on how to determine whether the truss is stable or unstable.